So far, we've been going from the equation for a trig function to the graph. Now we're going to reverse that and we're going to go backwards. So I have two half problems on the board. They're both from the book. 85 is an assigned homework problem. In a moment, I'm going to have you folks work this out. 86 is an even numbered problem, so it's not assigned. We're going to work through this one together. Both of the problems come in two parts. Part A asks you to come up with a formula that would give you this graph as a transformation of cosine, and part B asks you to do the same thing, but viewing it as a transformation of sine. Both of them ask you to keep the value of A positive. So they're saying don't do any vertical flips, okay? So if you're doing a transformation of sine, you're going to look for a starting point, which would correspond to a middle value on your way up. And if you're doing a transformation of cosine, you're going to start at a high point. Okay. Now, I've taken these problems from the book, so they're asking for things in the book's version, not the factored form. What I'm going to do is I'm going to follow those directions because those are the directions we were given, but I'm going to find it in factored form first and then just multiply it out to get it into the form that they want. Okay, so let's work through this one together. We're saying we want A times cosine of, now I'm going to just say this would be B times the quantity x minus C2 plus D. So all the numbers are the same except that the number I'm subtracting is different from their C, and I'll get that by just doing the distribution once I've found these numbers. Okay, so for A, that's going to be what does the vertical stretching, and I'm looking at this as a transformation of cosine. I can see the high value is at 4 and the low value is at -2. Looks like the middle value is at 1, and I can confirm that. The distance between 4 and -2 would be 6, and half of that would be 3, or equivalently 1 is halfway between 2 and 4. So if A is positive, its absolute value doesn't change anything. That's just going to be the amplitude, which is the vertical distance between the high point and the midpoint. So my A is just going to be 3, and I get that directly from the amplitude. B, that's the number that's going to tell me what the period is. So if I take a look, if we're viewing this as a graph of cosine, we're starting at a high point. So we would start at pi over 4, and we're at a high point again at 5 pi over 4. So that's where we end, and this is where we start. So I can see that the period is going to be that distance between them. So the period is 5 pi over 4 minus pi over 4. So that's just 4 pi over 4, or pi. But I know that the period, which I just determined is pi, is going to be 2 pi divided by the absolute value of B, but I'm going to keep things simple and choose B to be positive. If I'm coming up with a formula, there are lots of different formulas that would work. The simpler ones are going to have a positive choice of B. So I'm going to suppose that B is positive, okay, and then I'm just going to solve for it, okay. So this would mean B times pi was equal to 2 pi. To solve for B, I'll divide both sides by pi, and B is 2. And notice I did get a positive number. I knew I would because the period and the original period before transformations are both positive numbers. Okay. All right, so I've got my A, I've got my B. C over 2. If it's in factored form, or sorry, C2, not C over 2. C2, if we're in factored form, that's just the amount that I'm shifting things. We said we're starting here at an x value of pi over 4. So if we've moved things pi over 4 to the right, that would correspond to subtracting pi over 4. So I can say C2, that's just pi over 4. And D, that would be how much we've moved things up. Remember, for that, I want to be focusing on my middle value, because the high and the low are affected by both the vertical stretching and the shifting, but the middle value stays the same when we do the vertical stretch or shrink, but it only is affected by the vertical shift. So our middle value here was at 1, so we've moved things up 1, so D will equal 1. Excellent. Once I've got those four numbers, I can say y is equal to a was 3, cosine. Now I found this version. So b was 2 times x minus pi over 4 was my C2, plus d is 1. And then all I need to do to get this into the form that the book asked for is distribute that 2. So we would say y is 3 cosine of 2x. 2 times negative pi over 4 is going to give me a negative pi over 2 plus 1. So that's my answer here. Okay. So I'm basically looking at each one of these numbers is associated with one of those transformations. I'm looking at the graph to get that information and then coming up with the numbers. So pause the video, try working out 85b. Here they're asking you to find it as a transformation of the sine graph rather than the cosine graph. I've got the graph up here on the board, but I did specifically choose an example from the textbook so that you've got a perhaps easier to read graph in the textbook if you prefer it. So pause the video, work that out. See you soon. Just as with the last example, I'm going to rewrite this to find a sine. In factored form, it would be b times x minus c2 plus d. Okay. So C2 will be the amount that I'm shifting things horizontally, and then to get things into the form that we're asked for, we'll just distribute the b once we've found it. Okay, let's see. If we're viewing this as a transformation of the sine graph, that means I've got to start at a middle value. Now it looks like my low is 1, my middle is 3, and my high is 5. So here's a middle value, and we're on our way up. So that ensures that I haven't done a vertical flip, which is what's implied by the fact that A has to be positive. So it looks like my starting point is right here. Okay, now I can get the amplitude, and that's just going to be A. Again, if we were allowed to do a vertical flip, A could be negative. I'd have to take into account the absolute value. If we're told A is positive, it's the amplitude. That's the vertical distance between the high value and the middle value. Distance between 3 and 5 is 2. Nice. Okay. B is related to the period. So it looks like we were starting, we said, at negative pi over 4. We were ending, let's see, when are we back at that middle value on our way up? Looks like that's at 7 pi over 4. So the period is going to equal 7 pi over 4 minus negative pi over 4. That's 8 pi over 4. That's 2 pi. That's the original period. So we haven't done any horizontal stretching or shrinking. So B is just 1. Okay. Nice. All right. Now, if we're starting here at negative pi over 4, then I know I've shifted things to the left pi over 4. Okay. So that's going to correspond to subtracting a negative value. So my C2 will be negative pi over 4. That way, subtracting that is like adding pi over 4. Adding pi over 4 shifts me to the left by pi over 4 units. Okay, and then D is the vertical shift. Again, I don't want to look at the low and the high value because those are affected by both the stretching and the shifting, but the middle value is only affected by the shift. So prior to transformations, the middle value is 0. Now it's at 3, so we've moved things up 3. So D is 3. So I can say we're going to have 2 times sine of B is just 1. Oh, that's lovely. Times x minus negative pi over 4 plus D is 3. Distributing the 1 makes it kind of unnecessary. So I'm just going to simplify this and say this is 2 sine of x plus pi over 4 plus 3. Totally fine to go ahead and simplify that so that I'm not literally writing in the 1 and minus the negative pi over 4. But you'll notice that I've also told you what my A, B, well, C2 and D were. Okay. So if I were looking at this, adding pi over 4 is equivalent to subtracting negative pi over 4. So C is also, in this case, negative pi over 4. Good stuff.